Hello, my name is Anton Grishko. I'm Chief Architect at ProfiseaLabs, and I'm also platform engineer for the last 2 years. I'm working with a new product called Kubernetes.io. We're trying to build our own opinionated platform. And because of that, I have a lot of experience working with platform engineering, with different platform engineering tools, and I'm very, very deeply in this field. That's why today we're going to discuss what the platform engineering is, what's the difference comparing it to DevOps, what kind of tools you should or you can use with the platform engineering, and why this topic is so hot today. And we'll start with the first question.
What is platform engineering, and how does it differ from traditional DevOps?
So what's the difference between platform engineering and DevOps? The difference is very simple. Platform engineering is trying to shift everything left to give the developer a possibility to perform a self-service so that he can deploy something, he can check out something, he can build infrastructure by himself, while the DevOps is focusing on building the infrastructure layer itself. And he's building the models, he's building templates, but those templates are used by DevOps engineers, not by developers, while platform engineers building the templates for developers itself.
Why has platform engineering become such a hot topic in recent years?
Platform engineering is super hot topic recently and over the last couple of years, and the reason is very simple. Everyone wants to move faster. Wants to have a self-service, while DevOps engineers are usually a bottleneck because developer needs to wait once the infrastructure will be built. If the template is already available, developer will just take this template and execute it without even knowledge how it's running underneath and what it does. Another reason why platform engineering is so hot at the moment is because when you have a templates for everything, when you already have like all golden passes, you automated all the workflows, it's super easy to add AI and give AI the possibility to run those workflows, to think about those workflows and to fix those workflows.
What key problems does platform engineering aim to solve for developers and organizations?
Platform engineering is solving a very basic key problem. It's giving the faster time for developers to move the application. It's faster deployment, it's faster build, it's faster automation. It's less cognitive load on developers. Developers doesn't need to learn about Kubernetes or about the clouds, or about the VPCs. All of that is already abstracted. So platform engineering is basically a new layer of abstraction. It's like DevOps, and on top of DevOps, now we have a new automation or new abstraction, and only then we have a developer who is using that abstraction layer.
What is benefits and downsides of opinionated platform versus customizable?
The difference between the opinionated platform and customizable platform is super simple, but it's very hard to decide what's better for your company. Opinionated platform is the platform where another company or another team is already decided that this is the technology stack that you should be using. That this is the load balancer that you should use. This is the scaling option that you should use. This is the monitoring stack or logging stack that you should use. That's opinionated. So someone else already decided that this is the amount quantity of software that you should use. While the customizable platform is basically giving you building blocks, and you can build your own templates, you can build your own UI, you can build your own automation or your own workflows. The problem with the difference between those two options is also simple, is that with opinionated, of course, you depend on that technology stack, but you don't care about the templates. You don't care about updating the templates. You don't care about creating those templates, fixing security issues inside those templates, and so on. While for the customizable, all of those problems you will need to solve by yourself. You will need to build your own templates. You will need to update them, upgrade them, fix the security issues, and so on, so on. So it depends on the size of your company. If you are working in a large enterprise company, it's probably beneficial for your company to build a platform engineering team inside and build your own templates, build your own platform. But if you're working in a startup in SMB or your company is not that big, there is no need to do that. It's overkill. It's better to take opinionated that already checked and verified on the multiple productions.
Which tools and technologies are commonly used in platform engineering today?
Tools, that's my favorite topic. So what kind of tools platform engineers are using, and what kind of tools you should use? Let's split the tools at two different sides. So first of all, we have a tools that provide you a centralization. That could be Crossplane, that could be Kubevela, So this is the tools that actually will give you a possibility to create the abstraction layer, but this abstraction layer will be on your side. You will have some central account or central Kubernetes cluster with all the templates inside, with all the abstractions inside. And if user is running something, it actually will be executed in your central cluster. So that's one side of the tools. Another side of the tools that are trying to bring the actual abstractions to the customer side, to the closer to developer. So basically, you can create again abstraction, and this abstraction can be pushed to customer Kubernetes cluster or customer AWS account, and developer will be able to use that abstraction layer. Well, this abstraction layer will be executed or inside his account or from your Amazon account to his account. Those tools which fall into this category called KCP, for example, or CRO, for example, KRO. Those also the tools that you can use. KCP gives you ability to create your own custom resources, CRDs, and that's from Kubernetes. It's basically templates, and you can push those templates to the customer, and customer can apply them in his own cluster. While the CRO is the new project, which is part of the Kubernetes 6 at the moment, which is the very interested project. And you can wrap again multiple YAML files inside one single abstraction. And this abstraction can be on your cluster or can be on a customer cluster.
How to design IDP and what should be taken into consideration.
Designing the internal development platform. So let's talk first of all about what's the IDP is, what the internal developer platform is. So that's the platform that platform engineers are building, and that platform doesn't mean that it's UI. It can be UI. Usually it's UI. You probably heard about the project which is called Backstage. Backstage is open source CF project that provides UI on top of your templates. That's for platform engineers. That's for developers. That's where developers will find the templates and will execute them. So one of the options of IDP could be UI, as you guessed. But that's not the only one. You can build the CLI, and your developers can use the CLI. That's also can be the one of the IDPs. It can be CLI. It also can be libraries. You can create multiple different YAMLs or some SDK code, and you can push that code to the Git, and you can ask your developers to just import that code or import those libraries in their code, and that's how they will be managing or using infrastructure, creating databases. So that's also option of the IDP, the set of the libraries. So that's first. Now, as you see, depends on the CLI or UI or the framework that you're building. That's the first decision that you will need to make. Do you need to build UI or do you want to build the CLI? Or, for example, you on a Lambda stack, you have a lot of AWS CDK, and it's better for you to build everything on the libraries. That's first. You decided that, then the second part, as we discussed in the previous question, should it be opinionated or should be customizable? Do you want your developers to customize your templates? Do you want your developers to build some new templates on top of your templates? Or you want just your developers to use your templates that you decided? It's a very tricky question. Why? If you want to give a lot of customization, a lot of freedom to the developers, it will be harder for you as a platform engineer to create all of those if and else statements inside your code and think about all the workflows. But another way you can do opinionated, that you decided the templates, this is the workflows, that this is the golden passes that I have, and you will just give it to your developers and they will execute it.
How does infrastructure as code, IAC, fit into platform engineering?
Let's talk about infrastructure as a code and how it fits inside the platform engineering. Everyone knows about the Terraform. Terraform de facto is the king inside the cloud world, and DevOps engineers basically using the Terraform. Can platform engineering be together with the Terraform, or can platform engineering be together with the infrastructure as a code? Yes, it can. But there are but. Let's discuss it. First of all, you can build the platform engineering on top of the Terraform. You can build a good Terraform code. You can split it to multiple models on reusable pieces of the code, and you definitely can build automation on top of that code and give it to your developers to do the self-service. But with it for Terraform, there is a problem. Terraform is not checking the state of your changes by itself. You know that you need to run this Terraform plan to get the plan, to check the state, and only you will then click apply. And if you do a big module, it will be taking ages to run and check all the changes and differences. Terraform is lacking the reconciliation loop. There is no something which is constantly checking, is there any changes? Is there any changes? Is there any changes? Yes, and then it automatically applied. There is no such reconciliation loop. That's why Terraform is not great for platform engineering. You still can do that, yes, but it's not great. What's much better is GitOps approach, is using what we're using, Helm charts, Argo CD, Flux CD. Instead of Helm charts right now, it's very popular is QLang, Timony. That's how we can build our infrastructure. So instead of using the Terraform, it's better to build infrastructure based on the YAMLs, based on the JSONs, based on the controllers. Controllers is the future. So can infrastructure as a code be with it platform engineering? Yes, it can. Terraform is not perfect option. There are different options. And one of them is, for example, crossplane. Another one is Kubevela or Crow, Cratix. You can use all of that.
What role do Kubernetes and container orchestration play in modern platforms?
Kubernetes in platform engineering is huge. Basically, the whole platform engineering concept or like a field started from the Kubernetes. Why? Because Kubernetes provides this controller option. When you have controller for everything, you have a piece of the code which performs some action. You have a controller for deployments, which is responsible to create multiple pods and replace pods and so on. So that's the idea, that controllers are doing some kind of automation. And this concept is very, very suitable for platform engineering. Why? Because we can build multiple controllers which are managing a huge amount of infrastructure. Kubernetes right now have a new library called a new controller called the multi-cluster runtime controller, multi-runtime controller. So basically you can build controllers which are reconciled across multiple Kubernetes clusters. So yeah, Kubernetes is huge in platform engineering, and platform engineering will not happen without the Kubernetes.
What's the future of platform engineering over the next 3 to 5 years?
The future of platform engineering for the next 3-5 years is very, very bright. Why? Because think about it. When you're building the layer of abstraction on top of your infrastructure, so you're basically building the automation on top of your infrastructure, which means that you can build a self-healing infrastructure, which means that when user is doing some mistake, he accidentally deletes some security group, or he deleted the database, or he deleted, for example, some port, you can be sure that your automation will revert all those changes back automatically. You don't need to run your Terraform. It will be done automatically. No one will know that something happened because it will be fixed automatically. Another very bright thing about the platform engineering and why it's going so quickly adopted in a world is because it's very good fit with the AI. When you have a golden process, you have a templates inside your company, it's very easy to add AI, as I said previously. You can add AI, and your AI can check statuses of your resources. It can understand the difference between the statuses of your resources. It can check logs. So it's giving you another layer of automation on top of what you have.
How can platform engineering help reduce cognitive load for developers?
Platform engineering was built for developers. The whole idea of platform engineer is to fix DevOps, is to automate DevOps. We DevOps engineers, I'm DevOps engineer for the last 15 years, and we DevOps engineers will become a bottleneck for developers. This is why platform engineering was invented, to fix this bottleneck. And bottleneck is basically saying that, hey, I'm not the one who is owning your infrastructure. You should own your infrastructure. I'm the one who is building the templates, golden passes, workflows. I'm the one who is building security for you. But you are the one who is choosing which infrastructure to create, which pieces of infrastructure to use, because you're a developer. You're someone who is building the application side of a company. So the whole platform engineering concept was built for developers in order to fix developers' frustration over DevOps, to give developers experience, to give developer a possibility to quicker create something, to quicker fix something, to quicker choose different technologies. That's what the platform engineering is about. It's about making everything as simple as possible for developer, and developer doesn't need to know how it's working underneath.
How should organizations balance standardization versus flexibility in platform design?
Very hard question. Flexibility is always very hard in the platform engineering. Platform engineering is about building templates, about building abstractions. And of course, you are trying to make something complex as simple. But how simple it should be, right? It should be very, very simple that you just given 2, 3 different parameters that your developer need to fill in. Or your developer is asking you, hey, I want to change another parameter and another parameter, and you need to give him 10 parameters, 20 parameters. So this line is very, very hard. The line where simplification, you should go all the way to simplification, or you should stop in the middle, or on a 20%, on an 80%. That's very hard. How to figure it out? You need to talk to your developers. You need to go inside your company and figure out what's the pain. Should you automate something? And you should start with that.
How do you handle feedback loops between platform teams and developers?
And moving to the next question about the feedback loop. As I mentioned in the previous one, in order to figure out what to build or how to build, you need to talk to the developers. Because we are platform engineers building the platform for developers. They are our customers. The developers are using the platform, so they are our clients. We need to talk to our clients. We need to collect the feedback from our clients. We need to ask him like, hey, what do you want to get? Like, you want to get a faster build time. You want to get the logs about the build, or maybe you want to have the integration with your IDE that you can directly connect to your database, check what's happening inside the database without even going to any different place. So feedback loop is super important. Don't build just the platform that you can build. That's it's not a good way to do that. Better to, first of all, collect the feedbacks from your developers. What's the problem? What's the struggle? I will give you an idea. The market is moving really, really fast right now, and it's very, very hard for developers to keep up with the updates. You have a new version of Argo CD, new version of the Flux CD, new version of Grafana, Prometheus, new version of Kubernetes cluster, EKS or RDS, for example, on AWS. And you need to do updates all the time. If you will stop doing the updates, it's a security issue first, and a second, clouds, for example, AWS. Currently, they are enforcing fee if you forget to update your database or your Kubernetes cluster. So DevOps are constantly busy with updates. Can it be automated? Of course it can be. You can create a controller which will be doing the updates for you. It will be checking the latest version, then it will be updating it somewhere in your Kubernetes cluster and making sure that everything is working correctly and fine. So that's just an example.
How can platform teams embed security and compliance as code from the ground up?
Let's talk about security. So security is super important. Platform engineering is really good because you templated everything. You templated each and every action that your developer is doing. You templated each and every golden pass or workflow that you have inside the company. And because of that, you can put inside your workflows, inside your golden passes, a security layer. You can add something that makes sure that security is good. There are a lot of different tools that you can use in order to automate security, to make security as a code. One of the options, especially for Kubernetes, would be Kyverna or OPA, Open Policy Agent. So Kyverna is really great. You can build a really great security policy or policy as a code. On top of that, you can push it to Git. You can sync it with the Argo CD or Flux CD. And that's what platform engineers are doing. They're not forgetting about the security layer. They are adding it at the first day.
What are the biggest challenges in platform engineering?
What are biggest challenges in platform engineering? Um, that's an interesting question as well. As I mentioned to you, the biggest challenge inside the platform engineering is basically figuring out this simplicity. Should you go all the way for simplification or not? That's like a biggest problem. And also the second biggest problem would be is to figure out where the platform engineering is more suitable compared to DevOps. You don't need to automate everything. You always should start with the pain points. If you have a pain point, automate it. I will give you an example. When developer want to build a new application, he will need to go and create a Git repo. He will need to load this Git repo with some scaffold application that it has, some standard application that company has, then he will need to add a CI/CD for that. Then he will need to deploy it to some test environment or some feature environment, right? And someone need to configure all of that. Usually it's a Jira task for DevOps. So instead of doing that, you can automate it. You can create the automation, which will be doing exactly the same in those actions.
What metrics should companies track to measure platform success?
Platform engineering is all about KPIs. There is no point to do the platform engineering without collecting KPIs, collecting the metrics. What those KPIs and metrics could be: it can be satisfaction of your developers. It can be time to deploy. It can be amount of deploys, so quantity of deploys. If, for example, before platform engineering, our developers were doing like 5 builds a day, or 10 builds a day, or 5 deployments per week. Now they're doing 10. So you need to collect metrics, and those metrics are usually about your developer experience. So how quick they are working, how many tasks they're closing, how much of code they implemented. Did you found some bugs in their code? Did you security check something? Is their life simplified because they're doing quicker troubleshooting? Is your downtime on a production got smaller, or stability got better? All of that is KPIs that you should collect and measure. Without that, you cannot tell that platform engineering is helping you or not.
What are common anti patterns or mistakes teams make when building platforms?
Anti-patterns and mistakes that happens with the platform engineering. First anti-pattern is to build right away everything. So you have a huge amount of Terraform Helm charts and you decided, hey, let's put everything inside the backstage. Let's cover some, for example, with crossplane. I already explained that this is a mistake. You shouldn't be doing that. You should focus first of all on pain points and then move from the pain points. Again, if you're a small company, it's also a bad idea to go to the platform engineering on that day one. Think about it. If you're a young company, just started your startup, what, you need a DevOps engineer who will build and deploy your application inside the cloud, right? And it will take time for DevOps just to build this like infrastructure layer, build your CI/CD for everything, to build you the databases, bring up the Kubernetes, for example, and so on and so on. And if he will be doing the platform from the first day, you'll be waiting for this first deploy very long amount of time. So if you're small, platform engineering could be very, very overkill for you, except opinionated platforms, because opinionated platform will make you faster because you will get the infrastructure right away. Right. So the third problem, or the third biggest anti-pattern that I see is Terraform. I don't like Terraform with the platform engineering. Still, you can do that, but much better to do the normal Kubernetes controller concept. So doing everything as Kubernetes controllers. Again, Kubevela, Crossplane, you can use all of that to do that.
What role does observability and debugging play in platform engineering?
Yeah. And now let's talk about the observability stack, which is the monitoring, logging, and then metrics inside the platform engineering. It's a huge part. Actually, platform engineering consists of multiple layers. One of the layer is observability stack. Another layer is security. We discussed that. Another layer is the self-service for your developers, which is workflows doing some action. Another layer is catalog with the applications that your developer is deploying, right? Observability is always a big pain in each and every company because it's very huge. You can go very, very deep with that. What platform engineering is given like a framework. You have identical concept of your observability across the whole applications, environments, clusters. Like it's the same. So you can agree with developers that, hey, we have Grafana, Prometheus, Loki, Tempo. You can just use the open telemetry embedded inside the code, and we platform engineers automatically will collect the metrics from your application because we're expecting this, and this default values. Like and subscribe this video if you liked it. If you didn't like it as well, like and subscribe it, leave it, comment, and also check out the comments because we provided a very great deal for you. We have a discount of 20% for this platform engineering course. We will discuss in deep about the crossplane and Kubevela and building Kubernetes controllers from scratch using different frameworks. It will be very interesting. We'll discuss how to combine it together with AI LLM, how to deploy AI LLM. Come join. It will be very interesting. Discount below this video.